Hi class, we are now on the last section of 2.1. This is doing calculations with significant figures, also known as significant digits. They mean the same thing. So let's take a look at how significant digits and not reading them right can affect your answer. We want to look at the diameter of this ball. If we look at the diameter of the ball, let's understand how to read this ruler. What is certain and what is not certain? So now if we look at this, we know that this is a 1. It's certain. We know 2 is a certain. We no longer have any more certainty. So that means our next digit has to be an estimated digit, and that's going to be in the tenths place. So when you are done with your certain digits, add one more. That is the estimated digit. So in this case, we have 1 in the tenths place. That's it. So how do we get with 0.6, 0.7, 0.8? Well, you kind of have to visually draw a line where the middle is, where it would be 0.5, 0.6, 0.7. So I'm going to say and agree that this is 2.7. This is how I break it down, trying to tell you once you get past what you know, add one more digit, that is your estimated digit. So how does this play into calculations? Let's take a look at the next page. On this one, we want the circumference. So to get the circumference, we have to multiply pi by diameter. We're going to plug this into a calculator. So we're going to use these 3 diameters, multiply them by pi, and the calculator gives us 8 digits for each. Now, we have significant figures rules. This is where students have problems because you'll give me an answer and you'll say, I got it right. No, you didn't. If you didn't give me the proper significant digits, it's wrong. And students have a hard time with that. Why? I don't know, because the rules are very established in chemistry. I'm telling you, this is foundational information. It's never going to leave you. Once you covered it, it is expected to be covered and followed throughout every single assignment you do. It's not just a given here and there. You will always have to do this in all chemistry. So the best thing I can tell you is put the effort in now to learn it, and it will make your life so much easier. Okay, so here we have 8 digits. Nope. We are going to go by these digits here. Our answer will be 2 digits. Why? I'm going to cover the rules. I'll show you why. So in this case, our answer would be 8.16. I'm just going to go to the hundredths place. 8.48 or 8.79. These are 3 very different numbers from each other. So you have to be able to be comfortable reading these pretty accurately or pretty well in order to get 8.5. Because you're not going to get 8.5 here and you're not getting 8.5 here, and your value would be wrong. So this is where you have to learn how to do this. All right, so this is a slide I had in a previous section. I'm bringing it back because I want you guys to understand how to read a ruler. This transfers over to graduated cylinders in lab, which hold solutions. You read them all the same way. It doesn't change. So in this case, what do we know that is certain? Well, the difference between this one and that one is this one has markers in between. So this one's going to give more precise measurement than the other one. The other one had 2 sig figs. So we should expect more sig figs here. So what do we know? We know that this is between 1 and 2, 2 and 3. But if you get confused, try counting it. That's all you have to do. So in this case, let's see, 2. Can we go to 3? No, we cannot go to 3 because 3's here. So this is 10 lines. That means this has to be in increments of tenths. So 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9, and 3. So in this case, let's see remember I told you, once you get past what is certain, you are now going to add one more digit as your uncertainty. So we know for certain that this screw passes 1. We know it passes 1.5. It passes 1.6, and it passes 1.7. That's what the 1 and the 7 are. We no longer know what that is. That's where a digit's going to be added in the hundredths place. And that is where we're going to have to visually try to consider where it is, try to make a line in between here, and I'm going to say this is 1.75 centimeters. So hopefully this is starting to make more sense how to read these things. All right, now we're going to get to multiplication and division rules. These rules, again, are rules that need to be understood. You will not get an answer right just because you think you did. If you don't follow the rules, that's not right. This is foundational stuff. These multiplication division rules are actually not that bad to understand. It's addition and subtraction students have a hard time with. So the rules here, when multiplying and dividing, report the same number of digits as the least precise starting measurement. What does that mean? Simply, it means find the value that has the least amount of digits in it. That's going to dominate, and that's going to control how many sig figs you have in your answer. That's it. That's all it means. This is less precise than this. This has 2 digits. This has 4 digits. My value is going to be 2 digits. A vehicle travels 350.3 miles in the span of 5.2 hours. What is the average speed in miles per hour? Okay, let's break down. What does miles per hour mean? Per means one is above the other. So in this case, we have miles per hour. So one above the other. Not multiplied, one on top of the other. So 4 sig figs, 2 sig figs. Plug this in. Calculator is going to give you a huge long number. Where does 61 come from? Well, rules for rounding. If the first non-significant digit is less than 5, drop all non-significant digits. So in this case, I bolded 4. 4 is our last significant digit. 2 is non-significant. It's less than 5. So we drop everything after that. We end up with 3 sig figs. If the first non-significant digit is greater than or equal to 5, increase that less significant digit by 1 and drop all the rest. Same number applies, but now I have a 5. This means that I have to add a number to my last significant digit and then drop the rest because it's 5 or above. So I still have 3 sig figs, only now it's 0.235. So in this case, going back, these are my 2 sig figs. This is my non-significant digit. It's above 5. I add 1 to the 0. My answer is 61 miles per hour. We covered rounding. Here's another one, multiplication. Remember, multiplication means you look at the value that has the least amount of sig figs. That is going to control how many digits you have in your answer. So here we have 5.02, we have 3 sig figs, 89.665, 5 sig figs, and 0.10, 2 sig figs. So my answer is going to have 2 sig figs. And this is hard in the beginning. Write it on top. 3, 5, 2. Put an equal sign, write 2 above, even though you don't have the answer. That will help remind you that you need to have that many values, digits for your final answer. So here's my value. I have 2 sig figs. Look at the non-sig fig. It's 5 or less. Drop them. My answer is 45. Division. Same rules apply. 4 sig figs divided by a value that has 3 sig figs. So 4. Did I say 5? Didn't mean to. 4 and 3. My value in a calculator is very long. I have a 3 written here, so it tells me I have 3 sig figs, but I have a 9. It's above 5, so I have to add a 1 to this number. My final value is 0.966, 3 sig figs. Okay, now we're at addition and subtraction. Here is where everybody has a problem. Addition and subtraction, students try to keep the same rules across the board, and you cannot do that. Addition and subtraction rules are vastly different than multiplication and division. I brought up multiplication and division first because it's easier to understand. Addition and subtraction, repeat after me, is not the same as multiplication and division. There are students here that will try to do it and they will get the answers wrong. I'm going to show you why. These values do not care about how many digits you have on this side of the decimal point. They only care about what you have on this side. So when adding or subtracting, round to the last decimal point of the least precise starting measurement. Last decimal place. Not how many digits the whole value has. So, while training for a triathlon, you swim 0.43 miles, then bike 18.1 miles. What is your total distance traveled? First thing, line up the decimal points. Line them up because it's going to allow you to visually see where your values are. So in this case, I have the 2 is in the thousandths place. My 0.1 is in the tenths place. So when adding or subtracting round to the last decimal place of the least precise starting measurement, what does that mean now? We don't care about what's in front unless there is nothing here. The value that has the smallest amount of digits after the decimal point controls the answer. So if you need help, draw a line here and cut, and that will cut off. It will help you to see where it needs to be cut. So in this case, my answer is 18.532. If I draw visually, if you can see me draw a line here, these are my non-significant numbers. I'm going to count them off. Here is 18.5 miles. This is my final answer. It's based on how many digits I had after the decimal point. That's what determined how many. This could have 653,182.1. That's what you would have. It's where the placement of the digits on this side of the decimal point. All right. So this is the same, giving you an example of drawing a line. First of all, when you're first learning how to do this, set it up like this, line up the decimal points. This will help you. This is why I tell you you need to learn the tenths, hundredths, and thousands, and 10,000s. It will help you understand sig figs. If you don't, you kind of go blindly and you have a hard time with it. Draw a line. So out of all of these, it's the value that has the least amount of numbers closest to the decimal point. This 4 is in the hundredths place, and these other two are in the thousands. So the 4 is going to dominate. Draw a line. Line everything up still, so you can see that this is going to get kicked out because it's going to be based on two significant digits after the decimal point. 3 in total, but 2 after the decimal point. So 9.21 is our answer. What if you have a problem that you have to do multiplication and division? You have 2 separate rules. And this is where you'll have problems if you don't retain the rules for each step. So if a calculation involves multiple steps, wait until the end to round. Do not round until you get to the very end. Do not round until you get to the very end. Leave the values. I tend to draw little lines, and that helps me. So here we have a multiplication and division problem. So it's in parentheses, so we'll take care of this one first. 4 sig figs, 4 sig figs. Here's the answer. I put it here. Brought it down. Now I didn't line these up the way this one is, because I have been doing this long enough. I can see that this value is going to determine my sig figs. This has 3 sig figs after the decimal point. This has 1. So my answer is only going to have 1 decimal point after the sig figs. I didn't line this up, and you would need to check if I rounded or not. I'm trying to get you guys to be active. So write this out, figure out how I did this, make sure this makes sense to you. This is 2 steps with 2 different rules, and this is very common in chemistry. Okay, so here's another example of addition and subtraction. I'm not going to go over this too much, but this gives you an idea. Draw a line if you need to once you understand the rules. Subtraction is the same thing. Nothing changes with it. We line the decimal points up, draw a line at the next to the least value with the least digits next to the decimal point. That's how you're going to handle subtraction and addition. I repeat, they are not the same rules as multiplication and division. All right, so let's do a problem that has both. A chemist measures the mass of chloride in 3 water samples shown in the table. Together, the 3 samples have a volume of 2.31 liters. What is the average mass of chloride per liter of water? There's that per. So this means mass per liter of water. So I'm going to have a unit above and I'm going to have a unit below. Here's our table. It's not rounded. So the first thing I need to do is add these together. So I add them. I line up my decimal points, which are not really lined up as well as they should be. But this is where understanding tenths, hundredths is. So there's tenths, hundred, tenths, hundred, tenths, hundred, thousands. So my values here have in the hundreds. So I'm going to draw a line, and that means that 35.86 is my 4 sig. It's going to have 2 sig figs after the decimal point, but 4 sig figs in total. However, there's a 9. I am not leaving this 9. I'm going to leave it because we do not round until the end. So in this case, if we were done with strictly this problem would be 35.87 milligrams. But we're not. And we do not round it to the end. Why don't we round it to the end? Because if you round every time you have a problem, you get further and further away from the true value. So you don't want to do that. So we know that this is what it would be if it was just this, but it's not. So this is where I draw a line to let me know where I need to go, and I would write it in. So now you need to understand how to set this up. This is total mass over volume. Average mass, the average is here, and answers to per liter of water. Okay, so here is the total mass, which is what it's asking for, is the total mass, and this average is being multiplied. So I jumped ahead. These 3 samples are the total mass. Volume is below. So where's the volume? The 3 samples have a volume of 2.31 liters. We only have 1 value. That means that everything was taken with the same volume. So we have our 4 digits. The 9 is not included, but we are not rounding it. And then 2.31. Now we have multiplication and division rules. We carry everything over, and we know this is 4 sig figs, this is 3 sig figs. However, multiplication and division only care about the value with the smallest amount of digits, which is 2.31. So our answer is going to have 3 sig figs. We're going to drop everything out. Non-significant is less than 5, so our answer is 15.5. All right, so let's do some examples. Here is, again, when I put this together, I did not have access to the homework, so I'm using slides from other courses. So we're going to add these sums up and then give the answer with the correct number of sig figs. First thing, line the decimal points up. Line them up. Then take a look at where there are our tenths, hundredths, and thousandths. 6.4 has the least amount of digits after the decimal point, so you can either draw a visual line or you can highlight it. I put an underline. 3 is less than 5, so my answer is going to be 17.8 centimeters. And always bring down your units. If you can't do that visually, draw a line. Put a line and then understand what's on this side and what's being let go of on this side. Okay. Now, this is multiplication and division. We've already covered this. What about the units though? So in this case, I'm not going to go over the rules for multiplication and division, but this is 2 sig figs, this is 4. So that means that my answer is going to end up with 2 sig figs. Here's the calculated answer. It says non-sig fig is less than 5, so it's 86. However, we have to multiply the units too. Centimeters times centimeters is centimeters squared. This is area. This is length times width. So this is 86 centimeters squared. Units always have to be brought down or multiplied or divided. When you're adding, you don't have to do anything but bring the units down. So in this case, what I mean is centimeter, centimeter, centimeter. That's fine. That's it. You're carrying it with everything. Here, you have to multiply them. So this is squared. If you had another one, you'd have to cube it. You have to carry these through with the values. Units have to come with it. They're attached. Okay, so here's 2 problems. I'm going to just show the answers, and I want to cover B is far more important than A, and I need to tell you why. So let's, sorry, my TV just went off. I guess I had on pause too long. So A, 2.171 centimeters times 4.2 centimeters. I'm not going to go over the rules, but the answer is 9.18 centimeters squared. Hopefully that makes sense as to why. I think I'm past pause on my phone, on my TV. Okay, so that should make sense as to why A has 3 sig figs and centimeters squared. B, this is a very important one. 4.92 grams is divided by 1.64 centimeters cubed. What's the big deal about it? Nothing really, because the units are grams over centimeters cubed. That's density. However, it's the value, the numeric value. If you plug this problem into your calculator, most of you will only get 1 digit, and it'll just say 3. If you write down 3, your answer is wrong. Why? Because you didn't have the correct sig figs. This is where you need to understand that you override your calculator. Your calculator gives you a value, but it's not always correct. You have to follow and know the rules in order to determine what the correct sig figs are. In this case, you have the ability and the power to add a point, a decimal point, and 2 zeros, because you have 3 sig figs and you have 3 sig figs. So your value has to have 3 sig figs. If you have 1 sig fig, it's wrong. So your calculator will show 3. You have to have the knowledge to know that you have the decimal point and a 00 to add that to it. If you don't, this is where you're going to have problems. So I specifically put this problem as an example to help you understand that you have to follow the sig fig rules. Your calculator simply gives you a value. You have to fine tune it and trim it and do whatever you need to do to make sure you understand that you have to still supply the correct number of sig figs with your answer.